Hello civil engineers, I am Balu, I am an civil engineer. In previous video, we have discussed about introduction to engineering mechanics classifications and some basic concepts. In today's video, continuation to that, we will discuss about the system of forces, parallelogram of forces and triangle law of forces and Lamy's theorem. Firstly, we will discuss about the system of forces. Basically, system of forces is the combination of forces acting on a body is known as system of forces. And classifications of a system of forces are basically four types. They are coplanar and non-coplanar, concurrent and non-concurrent, parallel and non-parallel, and the last one, collinear forces. These are the four types of forces. Firstly, we will discuss about the coplanar forces. Coplanar forces are the forces whose line of action lies on the same plane are termed as coplanar forces. For example, this is the plane and the forces whichever acting on the plane are termed as coplanar forces. And non-coplanar forces are the forces whose line of action are in different planes. For example, the force is acting on the bottom plane and the force is acting in this plane and the forces are acting in different planes. The forces whose line of action acts on different planes are termed as non-coplanar forces. And the next one is concurrent forces. Concurrent forces means if all the forces acting on a body meet at a point are termed as concurrent forces. Concurrent forces, if all forces acting on a body meet at a point are called as concurrent forces. If we see the diagram, the force is acting in this direction and the another force is acting in this direction. The third force is acting in this direction. If the forces meeting at a point, this point is called as concurrent forces. If we take non-concurrent forces, the forces whose line of action does not meet at a point. For example, this is a horizontal force and here one force, here one force. The line of action of forces on a body does not meeting at a point. If we see here, this is termed as non-concurrent forces. And the third one is parallel forces. Parallel forces are the forces whose line of action parallel to one another are termed as parallel forces. For example, if we take the forces are parallel to each other, whether they are in same direction or is opposite direction, but they are parallel to each other. These are termed as parallel forces. Parallel forces are classified into again two. They are like parallel forces and unlike parallel forces. Like parallel forces and unlike parallel forces. Like parallel forces are the forces whose line of action is parallel to each other and in same direction. These are called as like parallel forces. And coming to unlike parallel forces, the forces whose line of action is parallel to each other and in opposite direction. These are termed as unlike parallel forces. And the last one, collinear forces. The final one in system of forces is collinear forces. Generally, collinear forces are the forces whose line of action is in same line, termed as collinear forces. For example, this is the F1, F2, F3. The forces acting on a same line are termed as collinear forces. These are the system of forces. The next topic is law of parallelogram of forces and the triangle law of forces. The derivation of law of parallelogram of forces and the triangle law of forces are not that much important in exam point of view. Problems related to these are important in exam point of view. Let me see one problem. Two forces of magnitude 60 newtons and 80 newtons are acting. Two forces of magnitude 60 newtons and 80 newtons act at a point at an angle 50 degrees. Find the magnitude and direction of resultant forces. 80 Newton forces acts in horizontal direction. The hint is 80 Newton force acts in horizontal direction. By using law of parallelogram of forces formula, we will find out the magnitude. That is the R equal to under root of p square plus q square plus 2pq cos theta. By substituting values p equal to 60 newtons and q equal to 80 newtons, the theta is 50 degrees. By substituting these values in formula, we get, let me see, R equal to under root of p square means 60 square plus q square means 80 square plus 2 into 60 into 80 cos of 50 degrees. The value of R is 127.164 newtons. The next one is the direction. Formula for direction is, the formula for direction is tan alpha equal to q sin theta by p plus q cos theta. This formula is also from law of parallelogram of forces only. By substituting values we get 80 into sin 50 divided by 60 plus 80 into cos 50. We get tan alpha equal to 0.050. We need to calculate alpha, so we are transferring tan from this side to this side. Alpha equal to tan inverse of 0.550, we get 28.7 degrees. Magnitude and direction of resultant of forces are calculated. This is the basic problem and simplest problem. Same as that, in this problem also we are going to find out the magnitude and direction. Let me see. Find the magnitude and direction of the resultant of two forces, 250 newtons and 150 newtons, acting at mutually perpendicular directions. Mutually perpendicular directions is the hint. Remember that it will use in solution. Solution, let P equal to 250 newtons and Q equal to 150 newtons. P and Q are acting perpendicular, mutually perpendicular in direction. Mutually perpendicular in direction means that is theta equal to 90 degrees. To find magnitude, R equal to under root of p square plus q square plus 2p q cos theta. By substituting p and q values in this, we get under root of 250 square plus 150 square plus 2 into 250 into 150 into cos 90. Cos 90 is equal to 0. Cos 90 value is 0. By calculating that, we get under root of 250 square plus 150 square plus 2 into 250 into 150 into 0. Cos 90 value is 0. So we are getting R equal to 291.54 newtons. This is the magnitude of resultant force. To find out the direction, we have another formula, that is tan alpha equal to P tan alpha equal to Q sin theta by P plus Q cos theta. By substituting values, 150 into sin 90 divided by 150, sorry, 250 plus 150 into cos 90. This value becomes 0. Sin 90 means 1, that is tan alpha equal to 150 by 250. We get 150 divided by 250, we get 0.6, but alpha equal to tan inverse of 0.6, we get tan inverse of 0.6, we get 30.96 degrees. That is, so the direction of resultant with horizontal force is P equal to 30.96 degrees. This is the calculation of magnitude, and direction is very simple in these problems. And now we are discussing one more problem that is related to law of parallelogram of forces and law of parallelogram forces only. In second problem we discussed normal to the first problem only, that is finding magnitude and direction only. But in this problem little bit moderate, a little bit change, that is, let me see, two forces act at an angle of 120 degrees. The bigger force is 60 newtons and the resultant is perpendicular to the smaller one. Find the smaller force. Here, by using the given data, we will draw the force. The two forces act at an angle of 120 degrees. First we draw the angle 120 degrees. It may be like this. Angle between two forces are 120 degrees. We can see that resultant is perpendicular to the smaller one, that is R is perpendicular to P. With that only, again this is 90 degrees. Resultant is perpendicular to the smaller one, that is we have to find the P value, and the bigger one is 60 newtons. By using law of parallelogram of forces direction formula, we can calculate the smaller force, that is tan alpha equal to Q sin theta by P plus Q cos theta. By substituting theta value, Q value, and that is alpha, the resultant is perpendicular to the smaller one, and we can see that alpha equal to 90 degrees. The resultant is perpendicular to the smaller one. By using that tan 90 degrees, the Q value, bigger force 60 into sin 120 degrees, the angle between the two forces is 120 degrees, so we are taking 120 degrees, and P plus the value of Q is again 60 into cos 120 degrees. The value of tan 90 is 1 by 0 equal to 60 into sin 120 divided by P plus 60 into cos 120. By cross multiplication, we get P plus 60 into cos. The value of cos 120 is minus 1 by 2 equal to 0. By multiplying 0 into anything, we get 0. P plus 60 into minus 1 by 2 equal to 0. 2 ones are 2 30s are, we get P minus 30 equal to 0. P equal to 30 newtons. The value of smaller force is 30 newtons. These kind of problems are asked in mid exams and as well as semi exams. In some cases, they will ask two forces Q and P. They will give and they will ask the resultant that we can directly calculate it through R equal to under root of P square plus Q square plus 2 into PQ cos theta. By using that, we can easily calculate the resultant. And sometimes they will give the smaller force and the resultant. You have to find Q value, the bigger force. They will give 3 forces and ask to find theta value. And also they will give 2 forces and 1 theta value. We have to find the another force value. Maybe they will ask resultant or other 2 forces. Thank you for watching. Please subscribe and do support for more videos. Thank you.